In this video, we're going to cover the important aspect of back pressure. Pressure relief valves on clean, non-toxic, non-corrosive systems may be vented directly to atmosphere. However, pressure relief valves on corrosive, toxic, or valuable recoverable fluids are vented into closed systems. Valves that vent to the atmosphere either directly or through short vent stacks, as seen here, are not subjected to elevated back pressure conditions. For valves installed in a closed system or when a long vent pipe is used, there is the possibility of developing high back pressure. In this example, and as you can see here, pressure from the closed system acts on the upper surface of the disc, causing a resistance to disc lifting and therefore to the pressure relief valve relieving capacity. For this reason, the back pressure on a pressure relief valve must always be evaluated, and its effect on valve performance and relieving capacity must be considered. A review of the force balance on the disc shows that the force of fluid pressure acting on the inlet side of the disc will be balanced by the force of the spring plus whatever back pressure exists on the outlet side of the valve. Now, if pressure in the valve outlet varies while the valve is closed, the valve set pressure will change. If the back pressure varies while the valve is open and flowing, valve lift and flow rate through the valve can be affected. As a result, care must be taken in the design and application of pressure relief valves to compensate for these variations. Now, back pressure which may occur in the downstream system while the valve is closed is called superimposed back pressure. This back pressure may be a result of the valve outlet being connected to a normally pressurized system, or may be caused by other pressure relief valves venting into a common header. In the first case, the back pressure is equal to the pressure of the downstream system. Assuming the resistance coefficients of connecting pipes and fittings are negligible. The back pressure in this case is constant. In the second case, however, the back pressure is generated by one or multiple pressure relief valves discharging into a common header. In this example, PRV3 is venting into the common header. See how the discharge fluid from PRV3 is also acting on the outlet side of PRV1, generating a superimposed back pressure. We'll call it PBack3. Now let's suppose that PRV2 is also venting into the common header. The fluid discharged from PRV2 will also act on the outlet side of PRV1, generating an additional back pressure. We'll call it PBack2. In this case, the total back pressure acting on PRV1 is no longer PBack3, but the sum of PBack2 and PBack3. So as you can see here, the superimposed back pressure on PRV1 is variable. Now, compensation for superimposed back pressure, which is constant, may be provided by reducing the spring force, as highlighted here. Under this condition, the force of the spring plus back pressure acting on the disc would equal the force of the inlet set pressure acting to open the disc. Now, when superimposed back pressure is variable, as in the case of multiple pressure relief valves venting into a common header, a balanced bellows design is recommended. A typical balanced bellow valve is shown here with its 3D view. The bellow, as highlighted here, is designed with an effective pressure area equal to the seat area of the disc. The bonnet is vented to make sure that the pressure area of the bellows will always be exposed to atmospheric pressure, and to provide a sign should the bellow begin to leak. With this design, variations in back pressure will have no effect on set pressure. Keep in mind, however, that back pressure may still affect flow.